guys, welcome to the last part of section 3.1, these videos. So I actually went ahead and already wrote out two definitions that we're going to need. So we're going to be now talking about proportion type problems. This is a special case of solving certain equations that have fractions. So first things first, we have to know what a ratio is. A ratio is a way to show the relative sizes between two quantities. So you can represent a ratio in one of these three manners. And then we also have a proportion, and a proportion is a statement that says two ratios are equal. So pause the video and just write down these two definitions and then hit play when you're ready to move on. So now what I want to do is I want to talk about how to actually solve proportions. So moving down to the two examples just below, I can show you kind of how to do this. So when you're solving proportions, it's a very easy way to solve these, because it's really, look at this, it's one fraction equals another fraction. That's what's telling you of a proportion. And so the nice thing with this is you can do this cross multiplication like this. So what I mean is you're going to have 2 times x equals 4 times 5. So that's what you actually have to compute. So this will equal 2x equals 20. And then you can just finish solving this to get x equals 10. So it'll be the same thing with the next one. You just have to be slightly more careful. So I once again just need to multiply across. But in this case, when I take 14 times x plus 2, I have to put parentheses around x plus 2 to make sure I multiply 14 times all of the top. And then for the other side, it's going to be 7 times 6. So now I can distribute. So I get 14x plus 28, and that's going to equal 42. And now I can go ahead and subtract off the 28. So I get 14x equals 14. And so then if I divide both sides by 14, I will get that x just equals 1. So that's kind of the idea behind these. So now what I want to do is I want to go to the next example, and let me give you some problems to solve. So for this first problem, I've got 4 over 7 equals 12 over x. Pause the video and hit play when you're ready after you've solved this. So if I solve this, I'm going to get 4x equals 7 times 12. So then I'm going to get 4x equals 84. And then if I divide both sides by 4, I will get that x equals 21. So that would be the solution there. So let me give you another problem now. So now I've got 2x plus 1 over 14 equals 5 over 10. So give it a go and hit play when you're ready. So for this one, so I'm going to take 10 times 2x plus 1 equals 5 times 14. So this is 20x plus 10 equals 70. And now I'll just solve as usual. So I'll go ahead and subtract off the 10. I get 20x equals 60. Divide both sides by 20, and I get x equals 3. Okay, so now we have a few problems to go through together that are word problem types. So let's check out this one. Okay, so proportion word problems, they are nice in one aspect because they have a very consistent way that you set them up. So that's one nice thing. I know a lot of times people hate word problems because it's like, I don't know how to set it up. But if you have a proportion problem, there's actually like a very common way to set them up. So you kind of get to bank on that. So let's read this problem. Drug dosage is frequently based on a patient's weight. For example, 260 milligrams of a certain drug should be administered daily for every 40 pounds of a patient's weight. What is the daily dosage for a woman who weighs 63.5 kilograms? Note, 1 pound is 0.45 kilograms. Okay, so first things first, my question is, where is the proportion in this problem? Maybe you want to read it over, pause the video, and hit play when you're ready. So the proportion is actually stated in this part right here. This is where the proportion is. It's milligrams, so I'm just going to note this. The proportion here is milligrams to pounds. That is our proportion. So everything needs to be set up in this order now. So you can kind of note the order that they gave it to you in. And this is actually 1/2 of our problem. So maybe I should actually write this in black. So it's 260 to 40. So you'll usually be given one proportion, and that actually makes 1/2 of your problem. Now, the other part of this is it's saying what is the daily dosage for a woman who weighs 63.5 kilograms. So notice that is not pounds. So we actually have a little bit of a conversion issue here. So I can't really go on with this for a moment. We need to first figure out what is this 63.5 kilograms. So this is a conversion. So I start here, 63.5 kilograms. And now I'm going to use this conversion rate right here to set up some dimensional analysis. So when I set this up, I want to make sure that my kilograms drop out. So I want to have kilograms in the denominator and 1 pound in the numerator as shown, because if I set it up like this, then my kilograms will drop out because they're on opposite sides of one another. So all I have to do to figure this out then is take 63.5 divided by 0.45, and that will give me her pounds. And this will come out to 141.1 pounds. Keep forgetting that L, don't I? Okay. So now I've actually got her weight. So going back to the structure of this problem. So this is why you want to write out like kind of the order of your proportions. So I've got milligrams to pounds. So now I'm going to put in that she is 141.1 pounds. And so the question here was asking what is the daily dosage? So that's the thing I don't know. So we're going to put in an X here. So now I can go ahead and solve this as usual. So maybe you want to pause and hit play when you're ready. So I get 40x will equal 260 times 141.1. So if I work that out, so I'm going to get that this is 40x equals 36,686. I'll divide each side by 40, and I ultimately get that x equals 917.15 milligrams. So that would be how much medicine to actually administer to her. And maybe you just want to round that up to just 917 milligrams. Okay, so there's one problem. So let's go to the next one. So now we're going to talk about something different, but this is still a proportion. So I want you to try to think about how this would actually get set up. The property tax on a house with an assessed value of $636,000 is $7,420. Determine the property tax on a house with an assessed value of $798,000, assuming the same tax rate. So the question here is, and you might want to pause to actually make a guess at this, how do we actually set up the proportions? This is all about figuring out the proportion. So if I just look back at this last problem, I want to set up something kind of like what we did here, but now I have to change it for the context of this. So I need something on top, something on bottom. So if you need a second to think about that, maybe hit play when you're ready. So when I read this over, it says property tax on a house with an assessed value. So here's the assessed value, here's the property tax. So here's kind of the order of things. It doesn't matter which way you want to go with this. If you want to do property tax on top and assessed value on bottom, that's fine. Or if you want to do the assessed value over the tax, that's also fine. But what I want you to do is I want you to actually just state for yourself what order you're doing this in so that you kind of can keep this in mind. So then I can actually set this up. It says 636,000 over 7,420. And so now I can go to the other part of this. Determine the property tax on a house with an assessed value of 798,000. So I know where this number now goes, right? It goes here, and I'm supposed to be finding the tax, so that's going to go there. And so now I can go ahead and solve this, right? So I have 636,000x equals 7,420 times 798,000. Okay, so let's go ahead and work this out. So we get some pretty big numbers with this, but I'll go ahead and just write that out. So if I multiply those together, so I get this crazy big number, because they are very large. And then if I just divide out by this 636,000 by each side, 36,000, then I'm ultimately going to get, so let's see, 636,000, that's $9,310 for taxes. That would be the tax rate for that house. Okay, so now we've got one more example. An island has 12 fur seal rookeries. Those are breeding places. To estimate the fur seal pup population in rookery A, 5,536 fur seal pups were tagged in early August. In late August, a sample of 1,100 pups was observed, and 185 of these were found to have been previously tagged. Use a proportion to estimate the total number of fur seal pups in rookery A. Okay, so you might be thinking, what the heck is this even talking about? So this is actually talking about how do you estimate animal populations. It's not like you can just conduct a census on animals, right? It's not like you can just force them to figure that out. So this is a method of how people actually figure this out. They use proportions. So this 12 is actually here to kind of throw you off. We're talking about a particular rookery. This is where seals breed. And so what they're telling us is that there were 5,536 pups that they actually took and they tagged them in some way. Later on, they go on and they pull out another sample of them, 1,100, and they count how many of them actually had those tags. And so from this, they're going to estimate what the population is. So you might want to pause for a second and think about what actually is the proportion here that we're talking about. So the proportion is actually being laid out in this sentence here. So it's how many pups they got, that sample, versus how many were tagged. So it's kind of this observed to tagged amount. That's the proportion that we want to maintain in this case. So in this case, I had 1,100 pups and 185 of them were tagged. So from there now, can I estimate what the total population is? Well, I know that in total they tagged 5,536 pups. So from here, I should actually be able to estimate the population. So that's what this is trying to get at. I know it's a little bit of a strange question to even think about, but this is the method. And so then we can solve this as usual. So I will go ahead and work this out. So I get 6,089,600. Divide both sides by 185. And so I get that this will equal 32,916.76. Now, obviously, you cannot have part of a pup. So we have to estimate this. So it's the total population, and we'll just kind of round that down, is 32,916. So that would be the answer. Okay, so that wraps up 3.1. So I will see you guys in other videos. If you have any questions or comments for me, please feel free to leave them in the comments. And otherwise, I will see you guys next time. Thanks for watching.